You know, so much of the code that runs our lives is a total black box, right? We just use it. Well, in this explainer, we're doing the opposite. We're going to shine a bright light right into the heart of a really fascinating project, the Helia Blockchain Token, to see not just how it works, but the deeper why behind it all. So let me just throw this question at you. We think of code as this super modern, purely technical thing. But what if? What if every single line was actually an echo of some of the biggest ideas in all of human history? Yeah, that's not just some hypothetical question. The Helia Blockchain Token is a real deal project, and it's built on exactly that principle. And honestly, it's pretty amazing. Look, this isn't just another crypto token. A better way to think about it is, well, code with a conscience. The folks behind it call it applied philosophy. It literally takes these huge ancient questions about logic and information, and instead of just talking about them, it puts them to work as functional code. I mean, think about it. What if instead of hiding its influences, our software proudly showed you its family tree of ideas? What if you could actually see the ghost of Aristotle or Alan Turing right there in the functions you're running? That's the core idea we're digging into today. Okay, but before we get into all the deep philosophy, we've got to understand the ground this whole thing is built on. Because none of this would even be possible without a really fundamental shift in how we handle data online. So the internet you use every day is all about asking, where is this file? It points to one server in one place. And if that server goes down, poof, the file's gone. This new web, built on stuff like IPFS, asks a totally different question. What is this file? It looks for the file's unique fingerprint, no matter where it is. And that simple change makes everything so much more resilient and permanent. And how does it do that? Well, it's actually a pretty slick four-step dance. First, your file gets a unique fingerprint, its own special ID. Second, the network acts like a giant global phone book to see who has a copy of that file. Third, you download little pieces of it from a bunch of different people at once, kind of like BitTorrent. And last, your machine puts it all together and mathematically proves it's the exact file you asked for. You don't have to trust anyone. It's just math. And the specific tool this project uses is Helia. You can just think of it as the next-gen, developer-friendly version of IPFS. It's modular, so you only use the bits you need, and it's built to run basically anywhere, in your browser, on a server, you name it. It's the perfect, flexible foundation for this whole experiment. Okay, so we've got our technical foundation laid. Now we get to peel back the next layer. And believe me, this is where things get really, really interesting. This is the project's philosophical operating system. See, that decentralized tech, that's just the stage. The real stars of the show are the philosophers. This project literally takes these abstract, powerful ideas from some of the greatest minds in history and turns them into living, breathing software components. And just look at this lineup. It's incredible. You've got Max Planck, the quantum physics guy, handling how values are defined. Leibniz, the inventor of binary, is powering the cryptography. Gödel is there, making sure everything is logically sound. Aristotle, yes, that Aristotle, is organizing everything. Shannon is analyzing patterns for security. And of course, Alan Turing is managing the state of the system. This isn't just a list of influences. This is a functional org chart for a piece of software. So that's the who. But how do all these intellectual giants actually work together day to day? Well, let's follow a single transaction as it makes its way through this philosophical assembly line. It's really like an assembly line of pure reason. A transaction comes in. First, Planck looks at it and asks, is this value valid? Check. Then Leibniz steps in and gives it an unbreakable cryptographic identity. Check. Then Gödel scrutinizes it to make sure it doesn't create some kind of paradox. Aristotle confirms it's following all the logical rules. Shannon gives it a quick scan to see if it looks suspicious. And only then does Turing give the final okay to change the state. It's just a beautiful symphony of logic. So that's the big picture. But to really get how deep this rabbit hole goes, let's shine a spotlight on just two of these modules. We're going to zoom in on Shannon and Aristotle and actually watch a huge abstract idea become a real line of code. All right, first up, Claude Shannon, the father of information theory. His big idea was something called entropy. No, don't let the fancy word fool you. It's basically just a mathematical way to measure surprise. A super predictable, boring pattern that has low entropy. A sudden chaotic burst of weird activity, That's really surprising. It has high entropy. So how does that become code? Well, here it is. The Shannon.js module is basically a security guard for the whole system. It's constantly watching the flow of transactions, and its one job is to flag anything that is statistically surprising, anything that's just weird and out of the ordinary. And this is why that matters so much. Instead of having a simple, dumb rule like block transactions over a certain amount, this system has a mathematical sense of smell for any weird activity. A coordinated attack on the network is, by its very nature, a highly surprising event. Shannon's idea gives the code a way to see it coming. Okay, now let's jump in a time machine and go way, way back, 2,400 years to Aristotle. His game-changing idea for us here is formal logic, this brilliant system for organizing things into clear categories and using simple if-then statements to make solid, logical decisions. And here it is. This is literally ancient Greek logic written in modern code. This Aristotle.js module is setting up a governance rule. The premise, or the if, is if a user has a balance of 1,000 or more, the conclusion, or the then, is then they get permission to create a proposal. It's a perfect, crystal-clear syllogism that a computer can understand. And the result is just so powerful. It means the rules of the system aren't buried in some developer's messy code. They're laid out in clear, auditable logic. It's moving power from arbitrary code to formal reasoning. And honestly, it's just stunning proof that the basic principles of how we think are truly absolutely timeless. So after seeing all of that, the tech, the philosophy, the code, you gotta ask the big question, why? Why go to all this trouble? Why does any of this matter, especially right now, in the world we live in? It comes down to this single, powerful idea from the source material. Every time a developer writes a line of code, they are embedding a worldview, a philosophy into that system, whether they mean to or not. This project just decides to be open and honest about what its philosophy is. And that feels more important today than maybe ever before, right? We're surrounded by these black box algorithms and AI that we can't see inside and don't really understand. This project is a radical act of transparency. It shines a light on its own intellectual DNA. And in doing that, the code stops being just a tool and it becomes a teacher, which leaves all of us with one final and I think really important question to chew on. This project was clear about its philosophy. But what about all the other software running our world? If every single computational choice really does reflect a philosophy, then what philosophy are we, collectively, writing into our digital future?